Hey everybody, I have a sample interview question for you today in Python. Here's the question at the top. Feel free to pause the video to read that over. A bit more information on the data set. It is a stock price data set based on the Black Skulls model. Here's a bit more information on that if you're curious. You can Google more if you want, but you don't really need to fully understand this in order to do this question. All right, again, pause the video if you need to read this over, get more information if you want. You can also download this data set I'll be using in the video description down below. But all right, let's get started. So here is a sample of 5 random rows in our data set. As you can see, our columns, and we have 1,680 rows total and those 6 columns. So if we start with our BS column here on the far right, I believe this is binary and should only have just either over or under possible values. And we can check that with the value counts. So df is the name of our data frame. BS is the column name. .value counts. And a good practice with .value counts is to include this drop NA equals false. The default value is true. And what this is going to do is it's going to show you how many null values the column has, if any, instead of just skipping it. So yeah, we can see it's all either under or over with no nulls. All right, so that kind of allows us to move on to our other numerical variables here. So value s, k, tau, and r. And I want to write a function here to be able to kind of do all of this EDA in one step. So showing distributions, null values, and descriptive statistics. So distribution, that means a histogram. So plotting a histogram to show exactly what the distribution looks like. Do we have any outliers? And then again, just being able to see that on a plot here. So let's go ahead and write our function. So define, and let's call this, you can call it whatever you want. I'll call it distribution. And now for our parameters. So first we need a data frame. So data, and we'll set the default equal to df. Now a column, so we're going to do one column at a time. I'll put this into a for loop afterwards. We can do it all in one line of code, but otherwise for each iteration of the function, we're doing one column here. So we need a column argument, and we'll set the default equal to value here, which is the first column. And we're plotting histograms, so we need to set the number of bins in our histogram. Each bin is going to be essentially a bar in your histogram. So we'll call this n bins and set the default equal to 50. And then finally, I want to set an x min and an x max. And the reason being is in case in any of these columns we have some pretty extreme outliers, I want to be able to essentially zoom in on where the majority of the data is so that we're not seeing a histogram where, let's say we just have a tiny bit of space showing like 99.9% of the data, a ton of blank space, and then one outlier way over on one side or the other. So these xmin and xmax will allow us to basically filter out outliers if we so choose. But on the default values, let's set xmin to a very, very negative value. So we're not cutting anything out by default if we don't want to. Then xmax, a very, very, very high positive value. Okay, so colon, and now let's define our histogram. So for data visualization, my favorite packages are in Plotly. So we're going to be using Plotly Express. This code, while I do love the interactive function of Plotly, it can be a bit tricky to memorize. So you can always go on Plotly's website to look up any of this. Okay, so fig equals, and then px is Plotly Express dot histogram. And we need to set our x. So x equals, and rather than just the column, we also want to filter on the rows. So filtering based on any x min or x max arguments. So let's use .loc here. So our data frame is called data. That's going to come from that input there. So data.loc, and then data column, that column argument coming from here in the function. And we want that to be between these values here. Whoops. So let's use dot between. The lower bound is x min and the upper bound is x max. Then for the column, we want a pandas series here, so only showing one column at a time. And that's going to be our column argument. So this is just a simple .loc here to show our pandas series. Okay, so now the number of bins in our histogram And conveniently, in Plotly Express, that argument is just called xbins, and it is going to be the same as our function parameter here. All right, then let's add a title of our histogram, and let's call this distribution of. And I want to do some text concatenation here. So we have static text and we have dynamic text. We'll add a space here so it's not all jammed together. Then plus, and then our column name. Okay, and I'm going to change the layout of this figure as well. So use fig.update layout. And again, you can find all this code on Plotly's Python website. I can leave a link to that down in the description below as well. So update layout. And for the hover mode, again, this is it kind of has a nice dynamic feature, these visualizations. So the hover mode, which I'll show you why I like this in a second, I prefer, it's called X. So I need this in quotation marks. X unified. And I'll show you why in a second. And then let's use an X axis title, and we'll set that equal to the column name. All right, then let's print out or show that figure. So fig.show. And now let's move on to our null values and descriptive statistics for these columns here. So we'll use a print statement. And again, I want static and dynamic text. So let's use f string printing here. And I'll say number of null values, colon, space, then curly brackets for our dynamic text. So that's going to be data, and then column dot is NA, and then dot sum. So that will show us the total number of null values in that column. Okay, and I want to leave a blank line in between this print statement and then our descriptive statistics, which will be down below. So within our print here, we can say comma and then end equals, in quotation marks, /n for a new line and then /n for a second blank new line. All right, now let's print out our descriptive statistics. So another f string here. So we'll say descriptive statistics, colon, and I believe I should be able to just add in new lines here as well. So /n/n, we'll go to a new line, and then curly brackets, so data column dot describe. And that should work. So let's go ahead and run that. All right, and now let's go ahead and run this through a for loop here so we can show all of our columns at once. So for call in, and I want all columns except for BS. So BS is our last column, or index -1 here. So df.columns, and then all except stopping before index -1. And then let's call our distribution function. So data frame is df. The column is going to be call, which comes from here in our for loop. Nbins, we'll start the default at 50. And then, yeah, we can leave these xmin and xmax at the default here. So we're not cutting anything out, at least initially. So let's go ahead and run that. Okay, so we have value first. And this is the X unified hover mode here. You see this line, this vertical line down. It just makes it very easy to see all of your bins. So that looks pretty normal. Looks like a nice long-tailed distribution. I don't really see any outliers here. We have some very low values here, count of 1 actually, but that kind of looks like it's part of the distribution. One null value, and here are our descriptive statistics. So then we have S. And this is an example of why we're going to want to zoom in on that distribution. So looks like we have a null value way over here, and all of these other bins in between are going to be blank. So we're going to want to use that xmin and xmax to zoom in here. All right, so one null value, and there are the statistics. And it looks like it should be roughly normally distributed other than the outlier if we look at the median versus the mean here, but we can check that in a second. Okay, then we have K, interesting looking distribution there with 2 nulls. Tau, again, looks like we have some outliers, so we're going to have the vast majority of the data found within this one bin. All these are blank. It looks like we have an outlier right there, as well as right there. So we'll go back and zoom in on that area as well. One null value, okay. And then R, interesting. So it looks like here, what we have are a discrete number of values. So if we look at these bins here, it's not showing a range, an X range, it's showing a single value. So I believe, and we can check this in a second, we have a discrete number of values here. 0 null values. All right, and let's just check, I believe it's R, yeah. So df.r, then let's do number unique. Yeah, so 20 here. So that means I believe we should have 20 bars here in our histogram. All right, then let's go ahead and look at zoomed in versions of our columns with obvious outliers. So I believe that was going to be, yep, it's going to be tau and s. So let's call our function again here. So we have df, and then let's do s first. We can stick with 50 bins for now, and then for our x min, if we look at where kind of this starts, let's do 425. And then our x max equal to 465. And that should give us a much better look at this distribution. Yeah, and there we go. Okay. It's an interesting looking distribution, but it doesn't look like there's anything too crazy going on there. And let's go ahead and do the same thing for, I believe it was tau. And that should be, I think the parameters in that one bar were -2 and 2. Let's cut the bins down a little bit. Let's do 35, make it a little less choppy. That looks better. Okay, so, roughly normally distributed there with that. I think it was at least one extreme outlier. Okay, so let's move on to dealing with our null values. Now that we have an idea of what's going on with all of these columns here. So let's create a new section. Use a markdown here and say null values. Okay, so df.isNA and then .sum. It's going to show us all the null values that we have. And now I want to see all of the possible rows, or any row where there is at least one null value. So how many null rows do we have where there's any, not all, any of those possible values are null? So we can say df dot isNA and then dot any, not dot all here, because if just even at least one of those values in any given row is null, we want to be able to show it. And then within dot any, I want access to be equal to 1, not 0. So we're doing it on the columns here. So if any of those column values are null, we want to show it in our filter. And then just in case, let's do skip NA equal to false. We should be able to put this right into a filter. So put that in brackets, then df on the outside. And there we go. Okay, so it looks like all of those null values are coming in just these 2 rows right here. So when it comes to null values, you really have 2 options. We can't have any nulls if we're going to put this into a machine learning model. So we can either drop any rows that have a null value, or we can impute. Impute meaning essentially estimating at what those values could be. So a good example would be we have S, K, and tau here, estimating what those values are based on the value for value as well as the value for R. So kind of estimating and saying, okay, we know the value is between 8 and 9 here. So let's take the average of all values where the value is between 8 and 9 and estimating and kind of plugging that in for S, K, and tau. That would be an option. For me here, I think we have a substantial number of missing values in each of these rows. And it's only 2 rows compared to, I think is, so df.shape. Yeah, 1680 total. So I'm kind of inclined to just go ahead and drop both of these rows, and I think we should be fine. So we can do df dot drop NA. It's going to get rid of all those. So now we're down to 1678. I'll say dot reset index, then drop equal to true. So dropping the old index and starting over. And let's go ahead and overwrite that. So this is our new data frame. So now if we go ahead and copy that and just take the sum of all null values, this should be 0. Okay, so now we're good to go. And we can move on to dealing with those outliers that showed up in the distributions. Okay, so to deal with outliers, in order to, I guess, statistically prove an outlier, this is where we are getting into standardizing our data sets. So standardization is going to be the z-score. And the kind of general definition of an outlier is something that is going to be, kind of depends on your definition, but 3 to 3.5 standard deviations away from the mean. In either direction, actually, we should add. In either direction. But you also kind of have to look at the context of your data set to make decisions of, what's an outlier, what should I drop, and what should I keep. Okay, so let's go ahead and write another function here. And this should allow us to see all of the outliers in our data set. But first, we need to do some z-scaling. So I can do, let's create a new data frame here. So we'll call it dfz equals df dot copy. And I can go ahead and drop this BS row as well. So let's go ahead and drop. And then columns equal to BS. Okay, so create a copy. And it's just going to have value s, k, tau, and r. So now let's go ahead and z-scale. So we can do this with a for loop. So we can say for I in dfz dot columns dfz I, and we're just going to overwrite these essentially with the z-scaled version. So the z-scaling is going to be the value minus the mean divided by the standard deviation. So this is going to be equal to, go ahead and copy this to make it faster, in parentheses, the value minus the mean divided by the standard deviation. So we can go ahead and run that. And let's get a look at our data frame, make sure this ran. Okay, so that looks good. So we now have a standardized data frame, and this will make it much easier to statistically prove our outliers and drop accordingly. All right, so now let's go ahead and write that function. So define our function, and I will call this outliers. And first, let's set essentially a z limit. So how many standard deviations away are we considering an outlier? And this is going to be absolute value again, because it can be in either direction. So we'll say abs_z, and we can actually force a data type on this. We can say :int, and by default, let's set this equal to 3. So we're saying here, this is the name of our parameter, the colon, and then int is saying the input has to be an integer, then equals 3 means default value of 3. Then a data frame, and then by default, we'll say dfz. Okay. So let's go ahead and do some print statements here. So we can say print and f-string. This will just kind of be the title here. So we'll say number of, actually, let's say this. We won't call them outliers. We'll call them number of values per column that are at least, and here's where the f string comes in. So this will be our dynamic text. So then abs_z, standard deviations away from the mean. And then we'll give this another line down to our next print statement. So end equals, then in quotation marks, /n/n. Actually, let's kind of try to center this a little bit. So we'll give it a couple tabs. So /n is going to be a new line, and then /t is a tab. Look at this couple tabs, kind of make it stand out and make it nice and centered. Okay, so now I want to be able to see the information for all of our columns here. So let's bring in a for loop. So for call in our data frame is going to be called data here. So for call in data, let's say this is essentially going to be an outlier counter. So I guess we can define a variable here. So we'll call this counter equals data, and then we're absolute value of data, and then call again coming from our for loop here. So where that is greater than or equal to ABSZ. So this is essentially a filter right here. And I want a counter. So I want the number of rows essentially that this filter is producing. So we want the length of this data frame. So I can say dot shape and then index 0, which is going to give us the number of rows. Okay. And then I want to print, and let's see, we'll use f string again. I'll say the column, colon, and then the counter. So we see our column name, and then how many supposed outliers defined by that value that we input for ABSZ. Okay, so the next line, and we can go out of our for loop now, and let's say dropped rows. So I want to show the rows now that are popping up with z-scores that have absolute values greater than or equal to our ABSZ. So essentially get a view of what we're dropping here at the end, so after our for loop. So we'll call this dropped rows, and this is equal to data. So then ABS data greater than or equal to ABSZ. Then I want to use .any again. So any rows that are showing up here, so any rows that have any column value that is greater than or equal to 3 in this case, I want to show up in this filter. This is essentially what this is a filter. So .any, and then let's set axis equal to 1 again. So on the columns, not on the rows. So any column value that fits this these parameters here is going to show up in my filter. And let's do skip NA equal false again. And let's go ahead and input our print statement. So print another f string here. I'll give this a new line to start with. So we're essentially just bumping this down one line. And then total number of rows to drop. Now for our dynamic text, and we want that to be dropped rows. And this is a total number, so let's make this dot shape 0, because this filter is going to give us a data frame. We want the number. So total number of dropped rows. We can give this an end equals // so we have a space in between. And now let's show those dropped rows. So we go ahead and just print our dropped rows. All right, so we can run that. And then let's go ahead and call our function. And first, let's just do it with those default parameters. So that's going to be setting ABSZ equal to 3. So rows, defining an outlier as a value that is at least 3 standard deviations away from the mean, and our default data frame. Okay, so go ahead and run that. And okay, so number of values per column that are at least 3 standard deviations away from the mean. So for value, we have 2. For S, we have 1. K and R have 0 outliers. Tau has 2. So we would be dropping 5 total rows based on this criteria. So let's go ahead and look at what are the reasons why we're dropping these rows. So first, we have index 12 here, and that is due to the, so tau extreme outlier there. I think that made sense if we looked at the plot or the distribution for tau. So that'll definitely get dropped. Tau again here, extreme outlier, so over 20 standard deviations from the mean. That's a lot. Index 205 here. This is a little trickier. So we have, so for value, 3.2 standard deviations away from the mean. Let's actually take a quick look back up at the distribution for value, because I don't think anything really showed up that was that noteworthy as far as outliers. So it looks to me like this is probably going to be the outlier that is showing up for value. Let's look at the max here. So the max is 60.1. So this distribution is showing everything. But to me, if we look at the graph here, the histogram, it doesn't really look like an outlier. It looks kind of like the natural long tail distribution here. This doesn't really look out of the ordinary. So I'm kind of inclined to go ahead and keep that. So let's look at these again. So let's go ahead and leave that row and move on to the next one here. Also, interesting to note, it looks like we have pretty high values. So high value for R as well. Negative 33 for S. That row definitely has to go. And then again for value, that looks like there are those 2 supposed outliers at the end of that kind of long tail distribution that I'm inclined to leave as well. So interestingly, in both of those rows where value has those kind of outliers, we have R, which is also very high. So actually, if we do a quick analysis here, let's say df.core, we'll see if value and R are correlated. So value and R not strongly correlated. Okay, we can look at K though. Let's see. So value and K. Okay, so this is pretty strongly negative. This is probably pretty strongly negative as well. So I'm trying to figure out basically if those values are more random, or we should expect that based on the other variables here. And it looks like we have a strong negative correlation with K, and that would make sense based on these values. So I'm going to leave these 2 rows here and here, and then let's get rid of this one, and this one. So if we call outliers again, and let's set this, we have 3.21 and 3.18. So if we set this to 3.5, we should only get those 3 rows. Okay, perfect. All right, so now we have essentially those indices here. So we have index 12, 33, and 87, which we now want to filter out of our initial data frame. So not DFZ, the initial DF. So let's write our filter, essentially. So we have DF as our filter, and then we want DF dot index. And let's write the is in, and then we can switch it to a not is in those values afterwards. So I need to redefine those dropped rows. So I can go ahead and copy this. Right here. So let's copy that. And let's switch this around. So this is going to be DFC, DFC. This value here is 3.5. Then those will all stay the same. So those are our 3 rows, and we want dot index there. So those are our 3 indices to filter out. We'll call this dropped index. Okay. So df dot index and then dot is in, and then dropped index there. So this should show us those same indices, but in the initial DF. There we go. So 12, 33, and 877. And now I want to make this a not in. So we can use the little tilde here, put that out in front, and that switches it from is in to not in. So we should get perfect. So we started with 1680. We dropped 2 null value rows, and now we're subtracting out 3 more. So 1675 total. And then last thing is I want to go ahead and let's just reset index and drop the old one. Drop equals true. So we have the same thing there. And we can go ahead and overwrite this. So df equals, and then that line of code right there. And there's our final data frame. So cleaned up, ready to go, got rid of outliers, took care of our null values, and we got a good feel for what our variables or our columns look like. So that is the end of the video today. If you enjoyed, you learned something new today, please go ahead and leave a like, subscribe if you haven't already. And as always, thanks for watching.